I'm a new addition to Excel as of January, and I'm actually based in Colorado. But having said that, let's get into the talk. Let me share my screen here. Let me get back to the top here. So one thing I wanted to bring to some people's attention that some people might be aware of, some people might not be aware of, is an interesting functionality and feature set that comes in Python called wrappers and decorators. Because Python is a first-class based language where everything is technically objects, there's a lot of features that you can take advantage of within your own code to do some nice fancy things that you might not have been aware of. So I'm going to do a really quick dive down into the actual meat of what wrappers and decorators are. I'm not going to get too deep into them, mainly because I have a Python notebook for you guys to look over if that is something you are interested in. And I don't feel like you guys really need to understand how to instantiate functions or anything like that. But just real quick, one of the things that wrappers and decorators are able to do for you is they're a way for you to extend other functions within your code base that might have some generally applicable code that you're wanting to apply to those functions, as weird as that may sound. You may have a bunch of different reusable code that you're using, such as like a validation for JSON or something like that, that you might want to be able to just wrap around a function or do some kind of error handling or debugging on top of that function with an easy, quick way to get in and out of that within your code base. There's also several other use cases that we'll get down into. But the essence of what wrappers are is essentially it's a function that wraps another function. So it gives you the ability to do other things out of the box that you wouldn't necessarily think of off the top. For instance, if we're going to look at something like this, where we have the power of 2, if we were to try and pass in a string, obviously this is going to fail. So one of the things that we can do is we can write another function to wrap or decorate that other function in a weird way here. This is kind of a weird way of doing it right here, which is why we'll get further down into the code here. But you can see here, we are using that power of 2 to basically do a bunch of different things, right? We're wrapping it with kind of doing just like a pass in right here as a parameter, but it's not necessarily wrapping it in the way that a wrapper should intentionally work. It's just kind of acting as like a normal function, right? So that's when we get down into what an actual wrapper is in Python, which is basically it's a new method function inside of an already established function that will call and return the other function. As hard as that sounds, it's like function inception, right? That's why this is kind of difficult to explain, which is why I didn't really do slides per se, and built this Python notebook so that you could kind of run through the execution processes of this notebook and kind of get a grasp on how this is working. But as you can see here, we have now taken that ensure numeric function, which just basically returns a typecast float. And we've gone in and we've now redone it with a wrapped inner function that returns this function that is being passed in. So that allows us to do something along the lines of this, where you're doing something very similar, but you're basically reinstantiating the function as a new function name. You could also just reinstantiate it back on top and it would do the same thing. But for clarity here, I've done a new name. So as you can see, now we can pass in string of 2 to this function. It will then go in and call this function that was being wrapped, either power of 2 or power of 4 here, with float x being typecasted on top, right? And then it will end up returning that new function instead. So basically we have encapsulated the original power of 2 and power of 4 functions with that other function that does the typecasting for us. But we've done it in a very generic way that we can now easily use that one function to wrap any of these other functions that we want to apply that functionality to. Does that make sense? I hope so. So there's another way of doing this that kind of cleans things up for you, that kind of makes it a little bit easier for you to use and read as you're going through and you're writing all of this code into your actual code base for whatever you may be doing. And this is useful on small scale. This is useful on large scale. I've used this on some of the most basic scripts for my early system administration days, all the way to full stack, full scale applications for large project. And you'll find use cases for this stuff throughout just what you're doing. And I actually end up having a set of examples and other code of snippets that I keep to myself. Some of these are in here, and most of them are also from another article. But they're also just nice reusable chunks of code that you can easily bring into your project and adapt it very quickly without necessarily having to change anything within the core functionality of your existing code base, if that makes sense. So if we see here, we have basically that exact same definition that we had before of ensure numeric, where we pass that function in. But Python has this thing called the operator, or also known as Py syntax, that allows us to essentially decorate the top of these functions with our wrapper and decorator function. And that is essentially doing the exact same thing as we were doing up here, right? We're basically wrapping it and reinstantiating, but instead of reinstantiating, we're just basically throwing that functionality right there on top from the get-go when we declare this function. And if we wanted to remove that functionality, it's just a matter of pulling that decorator off the top. So as you can see, that's already a very quick and easy way to apply a set of functionality around another function and be able to get it in and out for testing or debugging purposes, right? And you can see that this ends up giving us the same result. We get 4 and 16, right? Same as here, 4 and 16. So it essentially does the same thing, but makes the code much more readable. And I understand I'm going quite fast, and I will leave plenty of time at the end of QA. That's actually primarily what I'm trying to save most of my time for, is QA, because I do understand this is a very in-depth topic. So let's take a look at this example real quick. We're not going to go too deep into it, but we're going to look at how we can parameterize these decorators and wrappers so that we can add additional arguments to the wrapper or decorator to get additional functionality of what we might want it to do for that particular use case of the function that it may be wrapping. Bear with me. So here we can see we've done our convert numeric function here. We just defined it as an inner function here, just so that we maintain this within the scope of our wrapper and we don't dirty our code up and dirty scope up down the road. Just an organizational method right here, right? But then here we have this other thing here where we do another decorator, and we use this @wraps thing, which comes from func_tools wraps. Now, why are we doing this? Well, one of the things that I kind of skipped over real quickly was in Python, when you wrap a function and you return it, it's going to return technically the new function, right? So it's going to lose any identity or any of the attributes attached to that function or anything else that was associated with that function. So what this this func_tools wraps does, @wraps here, this decorator here, is it basically does some behind the scenes stuff that I am not too privy to myself, that basically patches things back together to make sure that when you return the function at the end here, right here, that it essentially maintains the identity and attribute set and all that great stuff of the original function, which is kind of important for debugging, logging, and that kind of other stuff, right? But the other thing that it allows us to do is it gives us an additional layer separating us from the actual function that we're wrapping, so that we can then parameterize the wrapper itself. So now we can put conditional statements within the wrapper. We can provide additional information on the wrapper. So if we have a wrapper to do, say, like a bunch of unit conversions, right? I know there's a great library out there, Pint, I'm aware of. But let's say we just wanted a really small, concise code base for doing basic unit conversions. We could write a wrapper that does a unit conversion, and one of the parameters could be, what unit, and then you can go on and convert things separately outside of all that stuff, right? So it's very powerful in how you can extend all of this stuff, and it's very powerful in how it allows you to kind of preempt, post-empt, and modify arguments and return values, right? And that's essentially what we're kind of doing here with this ensure numeric, right? So we've got this convert numeric function. We've got the new function which is this other wrapper that we are normally used to seeing with these other wrappers that we have been going over so quickly. And we can see here it's doing a bunch of things to where it's basically iterating through the arguments and the keyword arguments so that it can be a generic wrapper, right? And then basically does all that typecasting for the convert numeric right here, and then feeds those new arguments and keyword arguments into the wrapped function. And then we ultimately get this return back with the new wrapped function. And then we have to do this little fancy thing here to kind of do a special bit of things with how the decorators operate to ensure execution of the actual wrapped function. Again, it's kind of some fancy behind the scenes stuff that we're not going to get too deep into, but if you just kind of look here and you go over this, you'll see how this is being used. So now that we have that new decorator all wrapped with the new wraps and parameterized everything here, this allows us to use this decorator without parens, use the decorator with parens, and it also allows us to specify the parameters with arguments to the wrapper itself. So here we can see we're passing in to none of these here. Do we care about if it's not a number, or if it's not already a number, then it will just go ahead and convert it to a number. Whereas here, if it's not a number being passed in, then we're going to raise instead of convert, right? So here, if we look at the output, we're calling all of these functions kind of really quick. And we can see here it is doing all those conversions for us. We can pass in a random set of keyword arguments and arguments, depending on how all of these are built, right? These are all different functions built with different types of parameters of arguments and keyword arguments. And we can apply this same wrapper to all of them, right? And then we can see here, because power of 4 is using that raise if not true, it ends up raising for us. Down here, not a numeric argument will raise with value ASDF of type class string is not numeric. That's the argument. This is the exception we decided to raise up here. So I know that's kind of really quick, deep and dirty as onto what decorators and wrappers are and how they're built. But again, I'm not going to get too deep into that, because what I really want to get into is showing you when to decide to use decorators and some good examples and use cases of decorators, so that whenever you're going throughout your day building code, you might go, oh, you know what? I remember that talk that guy gave about decorators and wrappers. Maybe this is a great use case for it. Now I can do a quick and dirty rundown to figure this out, right? So one of the things that you're going to notice in all of these examples below and above is there's kind of a format and a pattern that you'll see kind of emerging from doing these decorators and wrappers. And that's the following here. You have the decorator function. Here's your ability to do something before the function, with the function if you need to. So if you needed to check to see if that function is valid and return a completely different function than what was wrapped, you could. And then here we actually have something where we have the ability to preempt to do something with the args and keyword args. Then we actually call our wrapped function. We store that in a return value sometimes if we want to do something with that return value before returning it. And then we ultimately return that return value of that called function. Then we have this little area down here underneath all of that before we ultimately return the decorator that does the wrapped function, which allows us to instantiate a bunch of different stuff when the decorator gets instantiated itself. We'll go into that in a moment when it comes to maintaining state inside of your decorators. So some of the examples and use cases that we're going to go over is one, timing a function really quick and easy. If you needed to see how long exactly a function was taking to execute, you were getting some weird timing issues or something just was seeming to take a little too long and you weren't sure where it was all happening, you could write this timer evaluation wrapper and go decorate a bunch of different functions with it and get timing so you could tell exactly which function, which calls were taking you the longest. And we can run that here and just kind of see how that operates. You can see wrapper began timing, then our function is sleeping for 3 seconds, then our function wakes up, then our wrapper prints out the execution time, right? So that's a quick, dirty, easy way to do a wrapper with timing. Now we also have the ability to, again, we could log a bunch of stuff for debugging purposes. So we could put it into a wrapper so that we could easily attach this to certain functions so that we don't necessarily have to get full debug logging across the entire application. We could go attach this one wrapper to this one function that we want to debug and not have to worry about enabling loggers all the way down within the module or even having a logger set up on that function, right? So here is the basic breakdown of that wrapper. You can see here, we're just essentially logging out what the arguments are, what the keyword arguments are, and then what the return value of that function, wrapped function is once we call that. So then we can attach that to a bunch of different methods here, a bunch of different functions here. And to kind of show you like where it really comes into power is like regression. So then we can utilize these, call these functions as we normally would, and now we get all this debugging that comes out with it otherwise that we wouldn't have, right? And we can see here when we're calling factorial, now we're getting all this printed output on this regression function, right? So that's very powerful whenever you're not exactly sure what's happening in your code, or you got a bunch of things that are going on where you might have regression happening. Very powerful stuff to be able to just attach a bunch of logging to it right off the bat and have that be a reusable, adaptable thing that you can move and use throughout your code, right? Without necessarily going into the actual functions themselves and modifying within the function themselves, right? So that's one great example for logging and arguments. Then we also have this retry wrapper. There's a really good article that I pulled this from. I actually had my own retry wrapper and then found this one. I was like, well, that one's actually done better than mine. So I'm going to adapt and provide credit. This is very powerful for something like where you have a connection to a remote server where the remote server is not always there available or rate limits you for random reasons or what have you. This can do a bunch of that retry capabilities for you so that when you're making those requests and that function error is out, you can catch that error and retry that function automatically again for you. Not going to go too deep into this one because there's a lot there to try and go over in a video chat. But as we can see it being used here, we have the decorator being used. It's a parameterized decorator. So now we're telling it what exception to raise, how many tries to do, and then the logger to use to log the events against the decorator. So then we have this test function that may or may not succeed. And we can sit here and we can rerun this block over and over again. We can see it failed the first time and then tried again. It succeeded the second time. So we can run that again. We can see here it goes, and it's doing a doubling of, power of 2 retry penalty. And it'll sit there and do that till 10 retries are a success, right? And that's just all by attaching this one retry decorator right here, right? So very, very powerful, very dynamic. and adaptable. We can see it succeeded on the 6th try here. Another thing that you may want to do is slow down execution, right? So here's another wrapper, and again, you'll see that same structure, slowing down execution. We can watch this countdown, 5, 4, 3, 2, 1. One of the other things, now that we can kind of understand use cases of these decorators, we can kind of start looking at other things like nesting decorators, right? So you can actually stack these decorators. You can have multiple decorators that you use in conjunction with each other or independently of each other. So we have that log arguments decorator that we built, and we have that slow down decorator that we built. So this will pause the execution. This will log the arguments and pause the execution for 2 seconds, and then give us our return values. So you can stack these all day long as much as you want. Ordering does matter to some extent, depending on how the wrappers and decorators are built. But generally speaking, they're all pretty stackable like this if you build them in the same structured manner like has been shown here. So now we can also look at doing something like with a class, using a class itself as a decorator, because again, functions themselves are technically objects. So you can technically use a class as a decorator itself as well, and then going in and overriding your dunders, your built-in dunders for init and call. So here we're using a class to essentially maintain state, right? That's one of the use cases for building a class and having objects, is to maintain state outside of scope. So here we have, using that class as a decorator right here, we're calling hello world 4 times. And we can see here we have that counter counting up 1, 2, 3, 4. So that class being used as a decorator in such a manner is helping us to maintain state within the decorator, if that makes sense. And it's only that state is being maintained only on this function here. So if we were to come in here and wrap another @count calls, we'll just say sky. This is something I meant to put in here but didn't. We can see that the counter is different for hello sky. So that's a great way to get count calls, call counts on your functions. So how many times is this function getting called throughout, this process? So another useful debug feature, or maybe even potentially a rate limit feature, right? You could build in rate limiting this way as well, using a counter and a decorator with states. One of the other things that you can do is, again, because functions are ultimately objects in Python, you can utilize attributes on the function itself post declaration. So bear with me here for a second, but we have essentially 2 wrappers here. So we have a count calls wrapper, which is essentially the same thing as what we had above, but instead of using a class here, it's being defined as a function, just to get this aspect across. So we have our count calls decorator, then we have our inner function that is the wrapper. Then we can see here we're calling that wrapped function, but then here we're setting up an attribute on the wrapper function of _count equals 0. So this is where we're getting our state against this function here. And keep in mind, because this is an inner function and we're returning here, this is only getting called on instantiation when that code is being read, I guess more like declaration would be more accurate. So then we're doing basically the same thing here with cache. We're building ourselves a little dictionary of cache returned values, right? So here's the passed in parameters as my key. The value is going to be the return value. So that way, if somebody calls that function again with the same parameters, I don't have to redo that work. I just pull up the cache dictionary by the key value and return the value out of that dictionary instead, right? So as you can see here, we're just checking to see if that cache key exists in our cache attribute on wrapper cache. If it doesn't, we go ahead and we set that cache key using, again, the args and keyword args to compile ourselves a cache key. And then we're storing that return value from the function within that cache key, and then we return that value here as well. So that way we can see, let's say we have a Fibonacci sequence. We can see this first one doing a Fibonacci of up to 10, and this one's doing a Fibonacci of up to 8. Well, if we run this, we'll see it only calls it a total of 11 times to return 55 for Fibonacci 10. Well, 8, it's going to go through the first 8 steps of the 10, right? So, well, I've already got all those values. So now all I got to do is just return from the cache 21. I don't have to go back and recall that Fibonacci method again, that function again. Hopefully that makes sense. But again, another quick way to do caching on top of some of your calls. You can also come in here and put in a, you could parameterize this cache wrapper and have a, history limit, right? Cache limit. So only cache the last 10 calls. So that way every time, or last 10 unique results or whatever you want to do, right? And then you just kind of put that functionality right here around, you wrap that functionality around that function that you're calling ultimately right here, right? So very, very powerful, very dynamic, very extendable. And finally, one of the last examples, this might not be a use case to most of you guys. I'm not sure how many of you guys build distributable modular modules for Python. But let's say you did build a module for Python or a framework for Python, such as Flask. You can introduce a very simple plugin system to your module using wrappers as well. So here we can see, or using a decorator. We're not actually wrapping the function here. We're just decorating the function. You can see we're not calling the function or anything. We're just getting some information from the function and returning it. We're not modifying it. We're not doing anything with it. We're just returning the same function being passed in. But we're registering, we're taking account of that function against our plugins dictionary for our module. Then we can see here in our run module function, we're going to print some logging statements, and then we're going to iterate through all of our registered plugins, and we're going to run our plugins. What happened here? Okay. Sorry. We're going to run our plugins. We're going to call our plugins here, right? So then this is our module code that's, inside the module. Just imagine the import structure, right? Then let's say here they are with their code. They define their plugin, and all they have to do to register that plugin is just decorate their either class or function or whatever you've got set up for that system. They just decorate theirs with that decorator that they import from your module, and that will automatically register all that stuff up for them and give their plugin access to your module. So then when you go to run your module, run this, we can see all these plugins get called and get triggered off and run. So just another powerful way of doing things. So I highly encourage you guys, if this is something you're interested in, if this is something you see as value to what you're doing in your day-to-day work, I highly encourage you guys, especially to look at this Real Python article. I've got it pulled up over here. That's where I got most of my information from to help build this talk. They go very in-depth. They go over all of the actual nitty-gritty pieces that you may need to have and want to know about functions themselves. So if you feel like something within that notebook is lacking, come over to this article and they're going to have the breakdown, and you'll see I have structured the Python notebook as kind of a quick and dirty companion to this article. So you'll see a lot of similarities across this article in relation to this Python notebook. Let me grab the link here for you guys, and I'll share this in chat to this notebook. Let me pop chat. It's going to let me pop chat. Yeah, here we go. So there's a link to this notebook. I don't know why Zoom doesn't recognize it as a link. I think we're all aware that's pretty easy to do as a programmer, but regardless, there's the link to the notebook. So if you feel like something is lacking in this notebook, I highly encourage you to come over to this Real Python article. Again, it is linked here at the very bottom. Right here, Real Python article, very in-depth, lots of examples. And you'll see I've also pulled a lot of these examples from their examples page as well. So that's essentially my talk. I'm opening it up to Q&A. Again, I understand I went through this really quick and dirty. I understand this is a very kind of complicated topic to try and describe verbally. So I completely understand if you feel like you didn't get something, do not feel like you're you're doing anything wrong by asking a question. I highly encourage it. This is the point. So, any questions?
What's been your favorite decorator? You said you've kind of been maintaining a collection of these, like of those, maybe not ones you've presented here, but like what functionality have you kind of incorporated within that that's been like either the coolest or the most rewarding for you, either in time saved or any other metric?
Yeah, I really like the caching decorators. I do a lot of Flask microservice design and implementation. So I really like the caching decorators because it's very quick and easy to go, oh, you know what? This is a function that that's kind of a long running function. We may want to take the effort to build in asynchronous. We may not want to take in the effort to build in asynchronous. Either way, we can throw in some caching to speed things up quick and easy, right? And that's a decorator that can be used across multiple things, not just Flask, but can be used can be this almost the exact same decorator if built right. You can use almost the exact same decorator for Flask as you can for Django. One of the other ones that I don't have here is you can build in some nice logging and debugging stuff for you to really kind of get a better insight as to what's happening. And then you can go and very easily wrap modules codes, right? So if you're importing a third-party library module, and you're not sure what's happening in here, you can throw a few of these logging decorators on top and get some better insight as to what's going on there, especially with like the call counts, right? Because there's some modules where there may be some regression going on and you're not exactly sure what's happening, and having these call counts may be beneficial to you or for profiling, right? The other one is that I find myself going to a lot. Again, I'm just now adopting this one, but I had my own that was very similar, but not quite as fancy as this one. Is this Retry, not Warper, but Wrapper, and mainly just because I do a lot of scraping, right? I try to do a lot of scraping of data to pull data down from a bunch of different web servers, web services. A lot of the time, it can be foreign web servers or web services, and the connections may not be very reliable. So this just helps automatically enhance the code and the success rate of the code, if you will, in a very quick and dirty, easy way. That if you just build one of these retry wrappers, it's easy for you to just grab and import into any of your other projects, right? That's where I find wrappers and decorators to be the most powerful for me, but that's because I span a bunch of different code bases, a bunch of different projects with a bunch of different purposes. Some are Flask, some are Django, some are pure Python, I'm kind of all over the place and where my development is and what I get involved in. And I also do a lot of DevOps stuff. That's actually my primary role is DevOps. I just happen to have a decent amount of dev experience on top. But having all these different decorators and wrappers like this in your tool belt and in your arsenal of weapons is really nice to have, because I can easily go in and be like, oh, I have a caching decorator. I have a logging decorator. I've got a retry decorator. I've got a slow down decorator. I've got a, counter decorator, yada, yada, yada. Right. And these are just quick and very concise ways that you may find as a great starting point for your decorators or wrappers, for you to then really kind of go and extend these a little bit further and put the functionality or the formatting in or what have you, right, for your particular use case, right? So, for instance, like Flask uses these decorators a lot in their framework. Django uses these decorators in their framework a lot. So just kind of knowing how the back end of them is working is somewhat beneficial as well. So that's kind of a nice to have as well. Any other questions?